Boleh nampak slide saya? Anybody? Can you see the slide? Boleh tengok slide?
Boleh dah.
Okay.
Boleh.
Okay, thank you. Okay, so for today, we will discuss on chapter 9 on group 15. We will skip for a while group 14. I have some issue with my laptop in which I lost the entire data for my drive. So I will firstly start with group 14 and later on when I can recover the data, so we will discuss on group 14. So for group 15, we will have the discussion on the introduction, the physical properties, and also we will discuss on two elements which are nitrogen and phosphorus. Okay, as an introduction, group 15 also called as nitrogen family. So it's called as nitrogen, sorry. So called as nitrogen family since the first element on group 15 is nitrogen. Group 15 consists of nitrogen, phosphorus, arsenic, antimony, and bismuth. So when downing the group, the metallic character is also increasing. So in which nitrogen and phosphorus is non-metallic, arsenic and antimony is metalloid, and bismuth is a metal. So regarding the valence electron, it will have the valence electron of Ns2 and P3. So that the total valence electron will be 5. So group 15 may complete the octet by 3 ways. The first one is accepting 3 electrons to form oxidation state of -3. So the example of element is Li3N, Ca3P2. The second way to complete the octet is by sharing the electron with 3 other atoms. So example here, we have NH3. And the third way to complete the octet is by removing all 5 electrons to form oxidation state of +5. But then usually group 15 will be stable with oxidation number of +3 and +5. Okay, so let's take nitrogen for example. Okay, so we look on this one first. For nitrogen, it having atomic number of 7. So it will have the electronic configuration of 1s2, 2s2, 2p3. Right? 7 electron. So for nitrogen, so we can write the Lewis structure of nitrogen as 1, 2, 3, and also another 2 electron. So to complete the octet, so it is either to remove 3 electron, so in which 3 electron from 2p orbital will be eliminated. So in this case, for example, just now we have Li3N. So Li will be, the electron from nitrogen will be donated to Li to complete the octet. and forming Li3N. So in this case, nitrogen will have an electron of 8. The second way is by sharing the electron. So since for this one, it is reaction between metal and non-metal, nitrogen will donate the electron. The second way is by sharing. So we put here number 1 is by donating. Number 2 is sharing. So again, nitrogen, we will have 5 electron. So 3 electron from 2p orbital may share its electron with hydrogen. So in this case, non-metal with non-metal. So it will form a bond with 3 other three other atom and forming a octet. So in this case, it will become NH3 and having 8 electron to complete the octet. So the third way is by removing all 5 electron. So in this case, if we use nitrogen as if we use again nitrogen as an example, so the entire electron in nitrogen will be removed. In this case, 2 electrons from 2s2 and 2p3 will be eliminated and only having 1s2 electron. So it will become only n. So in this case, the oxidation number will be +5. Okay, going back to the physical properties. So for nitrogen, with atomic number of 7, phosphorus 15. So if we see on phosphorus, it already go to n equal to 3. So meaning that they will be d orbital. So in this case, for phosphorus, it will have d0. So we have arsenic, antimony, and bismuth. For the ionization enthalpy, the first ionization enthalpy will be lower compared to the second and the third. So it having a similar trend when to remove 1 electron, it will require smaller energy and increasing when we want to remove the second electron and third electron. However, when we downing the group from nitrogen to bismuth, we can see that the ionization energy is decreasing. So this is due to the size of bismuth that is larger compared to nitrogen, and then the attraction of nucleus will be smaller. So that's why for bismuth, the ionization energy is smaller compared to others. Regarding the electronegativity, nitrogen having electronegativity of 3.0 and decreasing to bismuth to only 1.9. As the size is increasing when downing the group, the covalent radius and ionic radius is also increasing. The melting point, the boiling point, and the density is also increasing when downing the group. Okay, so the first element that we will discuss is nitrogen. So the occurrence of nitrogen, it is exists as diatom. So in N2. So it cannot exist alone as nitrogen. It need to have 2 atoms to form a nitrogen gas. So this will be the bonding of N2, having a triple bond. Nitrogen consists of 70% of atmosphere mass. So in our atmosphere, this will be the abundant gas in our atmosphere. It is essential in daily life. Even in our body, we will require nitrogen. So we consume nitrogen every day, and it can be prepared in lab by two ration. So the first ration is reaction of ammonia with copper oxide. So in this case, ammonia reacted with copper oxide, it will produce nitrogen gas, releasing water and reducing the copper. The second one is heating ammonium nitrate, so NH4 and O2. We will heat it at high temperature. It will produce nitrogen gas and also water. So if you heard today, there is a news at Lebanon, at Beirut, there is an explosion of ammonium nitrate. So ammonium nitrate is explosive. So it can easily, it been used for fireworks and also some what we call explosive work. So what happened in Beirut is that there is a large quantity of ammonium nitrate. If I'm not mistaken, it was 2,400 tons. It located in one place and it is exploded and making a very big disruption on Lebanon. You may see on the news. So in industry, nitrogen is prepared by air distillation and compressed into liquid form. Since in our atmosphere, we have 78% of nitrogen. So we can collect the nitrogen gas from atmosphere by air distillation. So this is an example of liquid nitrogen. So the nitrogen in air is compressed into liquid form. So we can see that this is nitrogen in liquid condition. And sometimes when you in road, you may find a tanker that carrying liquid nitrogen. So nitrogen is easily converted into liquid and easily transported by in liquid state. Now, the nitrogen is important for ammonia production. So ammonia production is called as Haber process. So ammonia is important for commercial nitrogen compound. So for example, ammonium salt such as ammonium sulfate and also ammonium nitrate are used as fertilizer. Ammonia can be converted into urea, which is used as fertilizer too. So in industry, Haber process is according to the following reaction in which nitrogen gas in reaction with hydrogen gas will produce ammonia. So the reaction take place at high temperature, about 500 degrees C, at high pressure, 10 power of 3 atm, and using iron catalyst. So it is high temperature and high pressure. So this is the loop of Haber process in which nitrogen gas and hydrogen gas is flown into a catalyst. So this will be the iron catalyst. So reaction will take place at high temperature and high pressure. It will be in gas state. So the ammonia is also in vaporized condition, and it will undergo a chamber that having a coolant. So it will be condensed and collected at the bottom of the condenser. So ammonia, it will be collected in liquid form. And then the unreacted nitrogen and hydrogen from the first reaction will be again circulated to the chamber and will be used again as a feedstock for ammonia production. So that's how ammonia is produced using Haber process in industry. So the second element is phosphorus. So phosphorus naturally occur in fluoroapatite rock in which CaF2, 3Ca3PO4 2, and in phosphate rock, Ca3PO4 2. And how do we extract phosphorus from fluoroapatite rock and also phosphate rock? is by heating the phosphate in silica and coke. Coke is carbon at temperature of 1500 degrees C. So let's say we have the phosphate rock in reaction with silica, it will convert it into phosphorus oxide, P4O10. And then the phosphorus oxide is reacted with coke, the carbon, and it will form phosphorus. In this case, it will be a semi-solid, it will be in liquid condition, and then sediment, when it is cooling down, it will be into semi-solid and produce 10 carbon monoxide. Phosphorus having 3 electrons: white phosphorus, red phosphorus, and black phosphorus. The white phosphorus, this is the typical look of white phosphorus. It is in white condition. The structure of white phosphorus is tetrahedron. So this will be the structure of P4. So if I can redraw it again. So we will have 1, 2, 3, 4. So this will be P4 in tetrahedron condition. So white phosphorus is volatile, waxy, white solid. It is dangerous, reactive in air, and glows with a white light and spontaneously bursts into flame. The melting point is 44.2 degrees C. The unconventional military use for white phosphorus is for phosphorus bomb. So if you read news during the war, white phosphorus is used as a bomb. So in which, in reaction with air, it will turn into a flame, and whenever it in contact with skin, human skin, it will continuously burn the skin until it is totally converted into phosphorus oxide. So let's say the white phosphorus is P4. In reaction with oxygen, it will have a flame and having a burning sensation. It will completely oxidize into P4O10, then only it complete the reaction. So until it complete the reaction, it will continuously burning into air. So that's why we can see that the population that been bombed with white phosphorus, they will have a major skin issue. Okay. The second allotrope is red phosphorus. It is a polymerized tetrahedron. So the tetrahedron from white phosphorus is rearranged into polymerized condition. So it is red in color, non-reactive with air at 25 degrees C, but then it is reactive at high temperature. So for red phosphorus, the melting point is 590 degrees C. And the third allotrope is black phosphorus. This is a layered tetrahedron. So the initial P4 white phosphorus coordination is what we call arranged in layered structure. So the form of black phosphorus is black in color, non-reactive at low temperature, but reactive at high temperature. So for this one, the melting point is 610 degrees C. So we can see here the red phosphorus and also black phosphorus. To change white phosphorus into black and red phosphorus, we will play around with temperature and pressure. White phosphorus can be converted into red phosphorus at elevated temperature over 280 degrees C. And the white phosphorus can be turned into black phosphorus by increasing the pressure into around 12,000 bar at very high pressure. Okay. The third will be the properties of P3 plus 3 and +5 compound, since we said that for group 15, it is stable at +3 and +5. Let's take PCl as example. So for +3, we will have PCl PCl3, and for +5, we will have PCl5. So the structure of PCl3 will be P with 3 chlorine, so we have 3 chlorine atom, and there will be excess of 2 lone pair electron. And for PCl5, so the remaining 2 electron from PCl3 is used for the bonding with another 2 chlorine atom. So in this case, the reaction of PCl3 and PCl5 will be different, since for PCl3 there is 2 lone pair electron, and this one can reacted as base, and this one will be acid. So this will be Lewis acid, Lewis base, and this one will be Lewis acid. Since 2 electron can be donated to another atom or molecule to form a new bonding, it will reacted as Lewis base. So for example, we have here PCl3 with 2 electron. So let's say we have boron bromide. So it can be donated to the boron atom and forming PCl3 . Okay, so meaning that 2 electron from phosphorus can be used to form one bond between phosphorus and bromine. Another example is, we use PCl3 again. Let's say we have here H plus. So the electron can be donated to H and forming PHCl3. So that's for PCl3. For PCl5, since there is no lone pair electron, but then in phosphorus, it has a electronic configuration of 3s2, 3p3, and in n equal to 3, there is 3d orbital, right? So in this case, so 2 already been filled, and 3 electron is used in p orbital, and for d, it will have 5 orbital. So phosphorus can use or utilize the d orbital to accept more atom. So for example, we have PCl5, let's say in reaction with chlorine ion, it can become PCl6 with the negative charge. So we need that. So 5 electron already been used for forming PCl5, and here it can accommodate more electron from chlorine atom. So for PCl5, it will reacted as Lewis acid, and PCl3, it will reacted as Lewis base. So with that, thank you.